everyone, welcome back to my YouTube channel. This is Parnika here. I'm back with my video presentations. Today I'll be discussing about OSI model and its layers. So, what are you waiting for? Let's move into OSI model. It is a conceptual framework that standardizes the functions of a telecommunication or computing system into seven abstraction layers. It was developed by the International Organization for Standardization (ISO) to facilitate communication between different systems and ensure interoperability. Each layer of the OSI model performs specific functions, and communication between layers is standardized, allowing different hardware and software to work together seamlessly. These are the seven abstraction layers that are present in OSI model. We'll be learning each layer in detail in the next few slides. Before that, let me explain you about TSP or IP model. This is not as popular as OSI model, but practically we use it for internet, and it is also known as internal protocol suite, which is a conceptual framework used for designing and understanding computer networks. It is not as strictly defined as the OSI model, but it is widely implemented in practice. The TSP or IP model is of four layers. The layers are network access layer, internet layer, transport layer, application layer. The TSP-IP model is the foundation of the modern internet and is widely used for communication between devices on networks. It is more closely aligned with the practical implementation of networking protocols and is the basis of protocols used on the internet. Different layers of OSI model. The pictorial representation of OSI model is from lowest to highest. There are seven abstraction layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Physical layer. The physical layer of the OSI model focuses on the hardware aspects of data transmission, defining characteristics of the physical medium, connectors, and signaling methods. For example, if we want to charge our mobile phone, we use a cable, USB cable, which is a physical layer. So this USB cable is an example for physical layer. It determines the bitrate, physical topology, and transmission mode, influencing how devices are connected and communicate. Devices like network interface cards and repeaters operate at this layer, ensuring the proper transmission of raw binary data over the network medium. Bit synchronization is crucial to maintaining timing between sender and receiver. The physical layer does not handle error detection or correction, leaving these functions to higher layers of the OS. The physical layer in OSI model is responsible for transmitting and receiving data over transmission medium. Data is treated as an unstructured raw data stream, the actual physical connection between the devices on a network. For example, coaxial cables, copper wire, optical fibers. Our next layer is data link layer. It transmits data from one node to another on a network. These first three layers are hardware layers, which as termed lower layers. It is reliable communication between directly connected nodes by managing data frame transmission. It is responsible for error detection and correction within the frames and controls access to the physical medium through protocols like Ethernet. The layer defines the framing structure and organizes data into frames for transmission. Network interface cards operate at this layer, and switches and bridges are devices that function within the data link layer, facilitating local network communication. Addressing at this layer is usually based on MAC, media access control addresses. Next layer is network layer. The network layer is the layer 3 between network segments. It is responsible for routing data packets between devices across different networks. It uses logical addressing such as IP addresses to identify devices and determine the optimal path for packet delivery. For example, if you're connecting to a Wi-Fi uh, institution Wi-Fi, you'll be having IP address like 192.62.36, etc. So these are the network IP addresses provided for each system which is using Wi-Fi. It's not only about Wi-Fi, the other communication channels. It uses logical addressing such as IP addresses to identify devices and determine the optical path for packet delivery. This layer ensures end-to-end communication by managing packet forwarding and addressing. Routers operate at the network layer, making decisions about the best path for data transmission based on network conditions. The network layer plays a crucial role in enabling global connectivity by connecting diverse networks into an internetwork. The next layer is transport layer. It ensures end-to-end communications across a network. It ensures reliable end-to-end connection between devices. It manages data segmentation, error detection and correction, and flow control to guarantee the integrity and order of transmitted data. Two commonly used transport layer protocols are Transmission Control Protocol (TCP) for reliable and connection-oriented communication, and UDP User Datagram Protocol for faster connectionless communication. The transport layer handles the establishment, maintenance and termination of communication sessions. It plays a vital role in providing a reliable and efficient communication channel between applications on different devices. Next layer is session layer. This session layer functions with two instructions, a request and response. It is responsible for managing and controlling communication sessions between applications. It establishes, maintains, and terminates dialog sessions, ensuring proper coordination and synchronization between devices. This layer facilitates full duplex or half duplex communication and handles issues like session checkpointing and recovery in case of failures. The session layer allows application to establish, use, and terminate connections for effective data exchange, while often integrated into the functionality of higher layer protocols. The session layer focuses on providing a structured and organized communication framework between applications. Our next layer is presentation layer. Layer 6, which performs data translation, compression, and encryption between applications. You might have seen a message popping up in your WhatsApp, like the messages are end to end encrypted, right? This function and this layer is important for that to happen and is primarily concerned with the format and syntax of data exchanged between applications. It acts as a translator between the application layer and lower layers of the OSI model, handling tasks such as data encryption, compression, and data formatting. The presentation layer ensures that data is presented in readable and usable format for the application layer, regardless of the differences in data representation across different systems. It plays a key role in enhancing interoperability by translating data formats between systems with different data representations. While often transparent to end users, the presentation layer contributes to the seamless exchange of information in a networked environment. The presentation layer, which will help the PDF to compress and send the same number of data bits to the receiver without missing any of it, is also a function of presentation layer. We will have a single bit error, multiple bit error, which can be resolved by using these OSI model and TCP or IP model. Seventh layer is application layer. It transmits the data in the form of a user readable format. This is the software or upper layer, which is very important for one to receive the data. It provides network services directly to end users and application process. For example, if we are receiving a message from the sender, the text whichever the sender has texted should be the same thing without any loss of information. This is a direct layer that is linked with end users, that is us. So, this layer enables communication and data exchange between software applications on different devices. Application layer protocols define the rules and conventions for communication between applications, covering a wide range of services such as FTP, file transfer, email, SMTP, and web browsing, HTTP. This layer also includes network-aware applications that directly interact with the network, facilitating user-friendly communication. In summary, the application layer serves as the interface between the network and the end user, supporting various high-level network services and applications. Thank you and have a great day.